TLS hitting the procedure that we have talked about before. I did that with the best intentions in mind, because really this is something you need to do over and over and over and over again. And then we can continue. Before I'm continuing, NK had a project. NK had a question. And that is, well, we can do it from here. That is done using OC create secret TLS. Do yourself a favor, OC create secret TLS -H. That is showing you how the command should be shaped. So it has a cert and it has the key. And based on that, hopefully you can figure out what you need to do. So I am going to use OC create secret. TLS, that's a secret type. Lingenx -certs, followed by --cert TLS.crt and --keys TLS.key. That's not keys, that is key in singular. And oh boy, cannot read TLS.crt. TLS.crt. Did I make an error? I think I did. Let me double check. This is where it is gone wrong. Do you see that? I made an error. I made two errors in this command. And I recreated, do you see that? I used -in TLS CSR, -out TLS CSR. Haha, that is not going to work. So that means that my CSR is incorrect as well. And that means that I need to start by regenerating the CSR and provide the common name again. Here you can see how easy it is to make an error. So lingenx -default .apps -crc .testing. That is what I want to have in the certificate signing request. Now that I've recreated my certificate signing request, I can use the out with a CRT instead of certificate signing request. And then I'm entering my passphrase, and ls-l is showing that I have a TLS CRT, a CSR, and a key. In case you are wondering, why didn't the command complain previously? Well, that is because it's up to you, the dear user, to decide what kind of output file name you want to create. You want to call it CSR, even if CSR already exists. It's your party. Do whatever you want. That is why it did not complain. This is really something that can bug you big time. Because try to debug it and to find where it actually went wrong. So going back to OC create secret TLS lingenx cert -cert TLS CRT -key TLS.key, and that's creating lingenx cert for me. Good. Let me do an OC get secret lingenx -certs -o YAML, because I just created the secret, and I would very much like to verify that it does have the TLS key and it does have the TLS CRT. And of course, this key and this CRT are base64 encoded, but they are still TLS keys and TLS certificates that we can see here. I like to check. You can see that they're starting with the same LS0T, LS1, CRUD, but then we see the 5Y whatever and the VQ whatever. That is looking okay. I'm doing that in the context of the typo that I just made, and I want to make sure that the certificate and the key are really different things. Okay, so now I have my secret ready, and in the secret I'm referring to the TLS key and the TLS certificate. So that is good. We can continue. And what am I going to do next? Well, next I'm going to create a config map again. That is not really essential for this procedure. But hey, it's in the procedures, so let me not try to skip it or whatever. This is in the EX280 directory, and there I have default.conf. And this default.conf, yeah, this is why we need a config map. This default.conf creates a valid configuration that allows me to access the application securely. I mean, the application is going to provide a page through a TLS port, so we need to have a configuration in the application that allows access to the TLS port. And as you know, configuration in OpenShift is not stored in the application image, neither in some configuration directory. You store it in a config map. So OC create CM on nginx config map -- from file default.conf. There we go, config map, nginx config map created. And OC create SA linginx -SA is going to do what? It's creating a linginx service account. And hey, I'm just realizing something. That's an interesting one. Can you have a look at the slide with me? Because something is not going all right here. The name of your current location. So I need OC new project default. And okay, I already have a project default, OC project default. We are going to use the project default. And OC get all is showing what's currently inside. There is not so much inside, but if my application name is linginx -default.apps-crc.testing, I need to create all of this stuff in the default namespace. So I need to repeat my OC create SA linginx SA, and I also need to repeat my OC create CM, and I also need to repeat my OC create secret. And oh boy, that is going wrong because of the directory name that is odd. And yeah, folks, I realize I am messing up, but I can promise you, you will make errors like this on the exam. And if you're not very aware of the relations that exists everywhere, then you'll be in trouble and you'll fail this assignment. But now I have recreated my secret, my config map, and my service account -z linginx -sa again. And that makes that the service account has access to the appropriate permissions. So now it's time to continue. And what are we going to do to continue? Well, we need to start the deployment. We need to create the pass-through route. And then in part 6, I'm going to show you how to test in a debug pod. This debug pod is a nice way of testing, not strictly necessary, but it's just showing another way of testing. So I would very much like to share it with you as well. But first, let's have a look at linginx -v2.yaml. That's a YAML file for the deployment. Now, what are we going to do here? Well, we are going to check the volumes. So that is the most important part. In fact, the bottom lines that you see here. There's a volume TLS search based on the secret name linginx search. There's a volume config map volume based on the config map nginx config map. We are going to mount these volumes. So etc nginx SSL, that is the location where we need these TLS files to be present according to our nginx application. And we make these TLS files present through the secret. Then we have the mountpad etc nginx conf.d, which is where the default.conf needs to be present, and that is provided by the config map volume. So this should be doing it. So let's use an OC create -f of linginx -v2.yaml. There we go. Now, last part is where we are going to create the pass-through route. So in the pass-through route, OC create route pass-through. And again, OC create route pass-through has a help. So use it, minus H. And hey, what's going wrong here? OC create route pass through. Oh, that's what we call a typo. Pass through minus H. Take two. So here we can see how it is used. And OC create route pass through. Basically, what you've got is a service name and you have a host name. So what are we doing here? Well, we are going to use OC create route pass through Nginx. That's the name of the route. Dash service Nginx Nginx v2 just 2. Sorry for that. Dash port port 8443. Dash host name is Nginx default.apps-crc.testing. Oh, I just realized that that is probably what I had in mind while creating this demo. So I told you that the host name of the route needs to match the common name in the certificate. That is something that you can have automatically generated. You can also make it specific while creating the route. So it was not really necessary to put all of this in a default product. But hey, I did, and this should work as well. So that means that I can even skip the host name, right? Let me skip the host name, as that should be created automatically. And because it's cool to verify that it is. So here the route is created. How do we verify? Well, OC describe route Nginx, and that should tell us that the services it is using is right here. And the requested host is Nginx default appscrc testing. Does that match Nginx default appscrc testing? Also, OC get SVC. What is OC get SVC doing? This is showing the Nginx 2, and this Nginx 2 has a cluster IP address, and this cluster IP address is later. So let me copy, and now let's go testing. And how can we test? Well, in this testing we use a debug pod. Now, why are we using a debug pod? Well, we are using a debug pod because it's cool to know that you can use debug pods. That's basically it. OC debug, that's how you create a debug pod. And the debug pod is a new pod that will be created in your current environment, in your current namespace. So that's a part of your current environment and should be able to access applications without any restrictions whatsoever. Debug pods are especially useful if additional restrictions apply, like not covered in this class network policy. So I'm using OC debug -t deployment /Nginx 2, which means we are going to run the debug pod in Nginx 2 --image registry .access.redhat.com /ub8/ub:8.0, and that is going to fetch the debug pod for me as a part of the current deployment. So that's the idea here. We are getting in the current deployments to figure out the testing. So I need to wait for just a little bit for the debug pod to start. This again is one of these situations where a container image needs to be fetched, and that can take about up to 1 minute. Should not take too long, but it is getting there. Make that UB9 UB. I want to go for the latest one, and not necessarily from registry.access.redhat.com. This is a debug pod that doesn't want to come up, and it really takes a long time. For that reason, I am expecting a problem with either the availability of the image or the accessibility of the image registry, and that's why I'm simplifying it a little bit. And if I really would like to further debug the debug pod, that is funny, debug the debug pod, then OC run would be my next step. I'm not sure if it is worth debugging debug pod. I will give it half a minute or so, as long as I'm still patient. I'm not patient anymore. Let me just use curl to https ://linginx dash default dot apps dash crc dot testing. And what is that giving me? SSL error system call. Oh boy, is that expected? Well, that might be expected. Curl minus svv. What do we get? Oh, SSL error system call in the connection to the Linginx. Is svvk making any difference? And svvk is still giving me an SSL error system call in connection to Linginx default apps crc dot testing. I'm not really sure why we are getting that. I'm also not sure if that is a problem that is even going to be fixed from the debug pod. In the slide, you can see on the debug pod, I'm using curl minus sk to the IP address. That would be the service IP address. The service IP address, well, we can do some troubleshooting and see if we can even access the service IP address on port 8443. So OC get SVC. And there we can see Linginx2, that is the name of the service. And I want to access this Linginx2. So let me copy this IP address and let me start by using curl minus sk on the Linginx2 IP address. Obviously, https ://10.2.17.550 :8443. Is that going to be any successful? That is not successful, for the simple reason that the service is of type cluster IP. I have a little trick in order to try to fix that, and that would be OC edit svc Linginx 2. And in OC edit, I am going to change the type to node port. It's a little bit of a dirty trick, but node port is exposing an external node port, and maybe that will make it accessible. So what do we get? We get OC get SVC, which is showing that now Linginx2 is of the type node port, and this type node port is doing port forwarding. So port forwarding on the CRC host to 3964. CRC IP is showing me the CRC IP address, and if I'm using curl minus sk to https ://192.168.130.11:3964, then I am getting nothing. So I am getting nothing, and that is not making me very happy. Just wondering if I have anything to say that makes sense about this at the moment. At the moment, I don't have anything to say that makes sense about it. I am going to analyze what I've done wrong while we are on a break, and probably this is a very good time to do some break time.